Alright, welcome back guys. Today uh, we will look into the question, alright, on LeetCode. Okay, so it was done here and no, it's this, it's not it, it is answer short, right? 560. It's a medium level question here. Oh, it's not there, right? What I can do for this guys is description. Okay. Alright. So the question is here. Given an array of integers nums and integer k, right? Return the total number. No, you have given integer array nums, right? And there is a integer k also given. You have to return total number of subarrays whose sum equal to k. Alright, you will return the total number of subarrays. Okay, and a subarray is a continuous non-empty sequence of elements within an array. Alright, so we can take this example and we can try run this version. Okay, the total number of subarrays we have to find, right? You have an array of 1, 2 and 3, right? And k is equal to 3. We have to find total number of subarray whose sum is equal to k. So one subarray is this and one subarray is this. That's 2, right guys? So how can we count those, right? Let's say we are going from here to here. Is this sum? No. Is this subarray sum equal to k? Yes, right? So here we have two subarrays like this, right? One subarray like this, right? Then we are adding this 3, right? So what we can do? So subarray is like contiguous always, right? So we can remove this and check both of this, right? After adding this, if it is equal to this, no, then also remove this. It is equal to this, yes. Now we have 2, right? So like that we can count it. Let's say take another example. 1, 2, 5, 3, 1, 2, right? And k is equal to 3 again, right? Or right? So this here we have 1. Here what we can have? No, 1 only, right? Then here 1 again, no, 2, and here we have 2 only, and here we have 3. Okay, I think it's a very easy question, right? we can do this. So we will have a vector, right? First what we can do is so we just need previous, right? And previous is equal to 0 on the count, right? And for int equal to 0, I less than nums dot size, right? I plus plus, and int current is equal to 0, right? All right. And in that case, int if, right, if current plus nums I is equal to k, right? In that case, count plus plus, right? Count will be there, and we will answer equal to count. Okay. If it is not like this, okay, but if count plus plus current is equal to plus equal to nums, no, not like, not here, right? Count plus plus if current plus nums I is greater than k, right? Then current is equal to current minus nums previous, right? Whatever the previous index is, right? Okay, we can do this like, not like this. We can do this like, okay, and previous plus plus while it is like this, right? If not, current is equal to nums plus is equal to nums I, right? Here, and current 0, answer and answer equal to 0, right? We just not okay, so we don't need these two variables, so just need count only, right? Count, right? Can we try run this? At the end we will return count from this. Let's try. What is the wrong answer? Output is 1, 2, 1, okay. So let's take this and we can write on this. Okay, yeah. So 1, let's 1 2 5 3 1 2 and k is equal to 3 only, right? So previous is 0 here, here is previous, right? And current is 0 and count is also 0, right? And I is equal to num star size, current plus nums I, so I is here, right? Is equal to k, no, so it is okay. Then while current plus nums I, k, okay, current is equal to plus num I, so current is now 1, right? Current is 1. Now I plus plus, now I is here, right? We are here. Is current plus nums I is equal to, yes, count plus plus, then count is 1, right? Okay, then we go, if current plus nums I is greater than k, not it is, then current is equal to nums plus I, and current is 3, right? 3, now I is here, right? If current it is not, then while current plus num size greater than a, okay, so previous is 0, right? Current is 3 minus previous 0 1, now it is 2 plus 5 is also there, then current plus nums I is greater than k, yes, then current is equal to current minus previous, then it is previous was 2, then it was 1, right? 0 from 1, now minus 2, it becomes 0, it becomes 2, right? Is current plus what is current now? No, count is or current is 0 now, 3 2 0, right? 0, count is only 1 for now, right? Count is only 1, right? Current is 0. Okay, one condition we have to put, and the previous is less than equal to I, right? Because we cannot minus the and previous is less than I, so right, that's it. Now previous was 0 1 2 here is less than I, no, then we are come out of it, right? Previous is less than I, okay. Current is equal to nums plus I, current is 5 now, right? Current is 5, and I becomes here 0 1 2 3, right? 0 1 2 3 4 5 here, and then this condition is false again, while current plus nums I is greater than k, yes, so, and we will minus this also, it is 0, right? and previous plus plus dbs is here now, right? This is equal to 3 and current is going now plus I, current is 3, right? Okay. I can put one condition here also, like if current is equal to k, then on plus plus, right? Okay, if it is condition comes out not, right? So current is what? 3. Current plus num size equal to k? No. Num size is what? I is here, right? 4. No. While current plus num size greater than k, as previous. Okay, I can put one condition also here. If current is equal to k, right, then count plus plus is the solution. What is the solution? Okay. Now output is 3, right? Output, so one extra is here. Okay, let me comment it out and try this. Again, answer is output is 2, 1, 3. Can I put it here? No, like this. Okay, it's accepting now. Some errors I have expecting here, guys. I don't know what, but because we are solving it right? What is the error? Let's check it. Let's take some help from here, right?
फेवरेट ड्रिंक मुझे आम जूस ना बहुत
Okay, so to handle the numbers, we must use the prefix sum plus mathematical like, okay, let's use the electricity meter analogy again. If the total electricity used up to day R in R and we want to find the So the question here is, guys, it is we have this unordered map, all right. A prefix sum of 0 has happened one time before the array starts. All right. This is necessary for subarrays that start precisely at an A0. So prefix sum of 0 is 1, okay. Current sum is 0, count is 0, okay. Current sum is equal to, we have added this, okay. The exact prefix sum we need to have seen in the past. Target past is equal to current sum minus k. If we have seen this exactly, this thing. If it exists in our history, add its frequency to our total count. Alright, if prefix history dot find target past is not equal to prefix history dot end, like something is there, right? Then count plus is equal to prefix history target past. Is recurrent sum plus plus. Alright, okay, then what is it is saying, doing correct, guys, it is. Let's take the example from here only, right? It will little bit lengthy example, right? Let's say this, right? And here Alright, so yes, that's the problem here, right? Now what we will do is we have this array, right? And your target is k is equal to 3. Now we have this prefix sum array, right? Let's say prefix sum array here. What is the sum here? 1. What is the sum here? 0. What is the sum here? Total sum 5 1 4 6 5. Total sum 3, and then total sum. But we are just finding like these sums, right? These subarray sums. We are not finding these sums in these sums. We are losing these, right? So what we can do to keep track of these sums is get a map of the sum, right? So let's say we have this map, and 0 sum is 1 here, right? Okay, one time we have count 0. Then current sum is 1. Okay, so 1 minus k is 3, so minus 2. Current, this is the target hour, right? Target sum. So minus 2 is minus 2 greater than 0, like it should be greater than 0, right? At the end. Now that map is prefix is 3, 0 is 1, current sum, okay. Now sorry, target person, current sum and sorry. If it is already there, then we do. If it is not there, right? Current sum plus. We have found this sum, right? Minus 2 is there, not there, so it is not a prefix sum. Then what we will do is we do 1 0 0. What is current sum? Current is equal to 1, right? So 1 1, right? Here we have this. Then we add this again, and current sum plus is equal to this. It is 0, right? It is 0. Then again 0 is 2 now, right? 0 is current sum is 0. Then current sum is 5, right? Current sum is 5, and 5 minus 3, 2 is not there, so 2 is not there, so it will for 5 is 5 is 1 time, right? Then we have minus 2, 5 minus 2 is equal to 3 current sum, right? Is current sum equal to this 3 is there, right? Current sum. So current sum minus k is 0, 0 is there, 2, right? 2 is there, right? So count is equal to this target passed. So count is equal to 2 here, but it must be 1, right? It should have been 1. Alright, how it becomes 2? 2, 1, 3. Then it is 3 here, right? And 3 plus 3 is 6. Current sum is 3, 3 is 1, right? And 3 plus 3, 3 minus 3 equals 1 is 2. It's a good solution, by the way. So let me write it myself, not dependent on the here, right? We have this unordered right map we have. Then what we will do is enter current sum is 0, right, and count also, right, enter count equal to 0. Now for enter I is equal to 0, I is less than nums dot size, right, and I plus plus, right. Here we have current sum is this. Then what we will do is we find the target, right, enter target past is current sum minus k. So if target past is the right map of target past, right, p dot find target past, right, is not equal to np dot end, right. If it's not there, in that case it is there, then what we will do, count plus equal to np of target past, right, and np dot current sum plus plus here return count. What happened? Well, this we have to do. Prefix tree 0 is equal to 1. Alright. MP 0 equal to 1. Now it should work. Right. Weight 52 only 1. Alright, then next question we had, guys, was this one. LeetCode 304, right? Here and here your problem set. Right. I will be back in a minute, guys.
అమ్మకు వచ్చి మాకు
Okay, welcome back guys again, and we were doing this question. You are given a 2D matrix called matrix, right? Right. Handle multiple queries of following type. So calculate the sum of elements of matrix inside the rectangle defined by its upper left corner, row 1 column, and lower right corner, row 2 column. Okay, implement the num matrix class. Okay, num matrix and try matrix. Initialize the object with the integer matrix. Int sum region row 1 column 1 row 2 column 2 returns the sum of elements of matrix inside the rectangle defined by its upper left corner and lower right corner. Right. You must design an algorithm where sum region works on order of 1 time complexity. Okay, it's a very prefix some similar. Okay, order of 1 we have to do, then what we can do, we can have this a private vector. Okay, which is vector of int, right, prefix, right, and here we have this int m is equal to matrix of size, int m is equal to m here and m here, right, equal to matrix 0 dot size here, right. Then we can initialize this prefix dot assign, right, m comma n m plus 1 comma vector of int n plus 1 comma 0. We can do this, right? And now what we can do here in prefix, that when we are let's take this only. Okay, take this here and right, alright, let's take this one, right? If we make so rectangle is this, right, left one, right one, and left 2, right 2. So if we are here, this prefix sum is here. If we are here, then prefix sum is this plus this is 3 only, right? So let me create this, let me draw it from the visual. Right. then we will have these 1, then 2, then 3, right, and 4. How many it is? 1, 2, 3, 4, 5, right? 1, 2, 3, 4 and 5 it is, right? So here we are, and this is 3 only. Let me change the color just for 3. Oh, this is 3, right? And here we have 3 sum, we have 4 sum, right? Then we have total sum what we have here, 4 plus 4, 8, 10. If someone asks me what is the sum of this part, then here 10 minus this part 4 is equal to 6, right? Right. And similarly we have this rectangle 5, 8, and this rectangle is because this is all of this we have to compute, right? So how can we compute it, guys? Up, left, 11 plus 6. No, not like this. From left to right, right? But we have to take care of this also, right? For this, what we have to do? 8 minus 3, okay, which is 5. No, we can do just like this. All of this, we have to save all of this. Can I do this here? Yeah, like so 8 minus 3, which is 5, plus 3 minus 3, which is 0, 3 minus 3, no, 3 it is, 3 minus 0, which is 3, and no, so 8 minus 3, which is 5, then 3 minus 3, which is 0, and 3 minus 0, which is 3, 8, plus 6, which is 14, right? Okay, then we are here. Then how can we calculate the rectangle, sum of the rectangle? By 14 it is, right? So 14 minus 8, which is 6, and how can I find the sum, right, of the whole rectangle here? Oh, 14 minus 8 is 6. Okay, 14 minus we have to find it for this, right? Or I can say 14 minus 3, which is 11, and 4 minus 3 is 1, 3 minus 3, 0 is 0, which is 12, plus 3, which is 15. Is just 15, is it? No, it is not from 7, it must be 18, right? It has to be 18. So how can I solve this? Like 14 it is, max is 14, plus 17 plus 1 is 18, or is, I can do just like this. No, can we do this? And 0 here, okay. What we have here? Here, what is the here? See? Here we have okay, we can do like what is the greater thing, right? Here row is equal to 2 and column is equal to 1, 2, 3, 4. So column is greater, right? When column is greater, then what we do is 18 plus 2, we go for row. Column 18 plus 2 plus 4, right, which will be 20, 24, right? It is 24. Now column become this. Okay. Then column is this. Then what we can do is 24 plus 1 plus 2, 27. Now row is 3, column is 1, right? When row is greater, then what we do? We take from the row, right, and add the value only. So 8 plus 1 is 9, column is 1 only, right? So column, alright, then what we do? Then row is 3 and column is 2 now. Row is still greater, right? Then what we will do in this rectangle? 14 and 9, right? So how can we do this? 14 we are taking from the row, which is very less, so we will take from the column, right? So we will take the value from the column, and so it will be 9 plus 6 plus 2, is it? So 16, is it like this? 9 from here, 9 or 7, 16, correct? Now we are here in that value, right? Here row and column are equal. Now what we can do? We take so when row was bigger, then we were taking the sum from the row, and if both are equal, then what we can do? We can take the sum from the both, right? 16 plus 18, which is very much. So what is the solution here? 8, 9 and 8, 17 and 4. 17 plus 4 is 21, right? So how can we take this 21, guys? So whatever sum is minimum, so 16 is minimum, plus 2 plus 3, 5. It is 21. And here we have a column is 4. When column is greater, guys, column is greater, then in that case what we will do, from greater we take, or here we take the sum from the left column, which is 21, right? 21 plus 2 plus 1. 21 plus 24 it is. No. Yeah, it is 24. Yes, it is 24. How it is like only 24, guys? Because it's increased from here to here. It is not 24, guys. So, okay, we take the sum from here and value from here. Right? Is it like this? 24 plus 1 is 25 only. I 25 only. 9 and 3, 27 it should be, right? What I'm doing here. Alright, so here, what the hell, brother? Like, this will take place like this only, okay? And let's continue also. 27 must be, how can we get 27 from here? 24, 21 here. Why 21 only? There was when it was equal, right? Then we have to find something like, okay, 3, 5, 1, 6, 2, 3, 9, 6, 2, 8, 9, 17, 3, 21 it was, right? So if we have 21 here, then how we are increasing in the column, right? So we take from this sum, advancing in column, then 21 from here. Should we take the max also, right? So max 24 here, then what? Then sum also, then 24 plus 3, 7, okay. 27 it is. Then here 27 and 27, 27 plus 1 is 28 and plus 5, which is 33, right? Is it 33, guys? Let's check. Okay, so 3, what is this row? 6, 5, 7, 3, 10, and 5, 16, 17, 27 and 6 और 3, no, it is 36. What? I am getting 30 only, okay. 27 plus 128, 33. What? Was it 27 then? Here it was 21, then it was 28 here, right? It was 28, guys. Because here it is 21. Now we are adding these all three, right? So it is 24 plus 125, no, 21 plus all of them, which is 27. Means 7 plus, so 28. How can we get this 28? It is by here 24, 21 plus no, it's very confusing here. Let's go to our not very hard, but we have to find the mathematical. Okay, so imagine a 2D matrix as a geographical map of a city grid where each cell contains a certain amount of revenue. C planner wants to know the total revenue generated within a specific rectangular strip on top, like okay, whatever it is. create a master ledger. Okay, prefix matrix. In this ledger, every coordinate r comma c stores the total revenue generated by enter rectangle spanning from the absolute top left. Okay. When the planning a specific variable, let our master ledger be p. P is equal to 1 index p about the outer bound sector slashing the edges. Okay. Building the master ledger with p count. So take the sum of rectangle above p I j minus 1 comma j p I comma j minus 1. Add the new physical value this with the overlap because the above and left rectangle overlap accidentally added left pi minus j minus twice. We must subtract it once to correct the equation. Oh, that was just like this. Okay. And that is above the target zone and subtract the rectangle. Add R1C. What a So you can see here, guys, like okay. So whatever the prefix sum is, this is 3 0 1 4 2, right? All of them are 0 here. This buffer is 0, right? Then here plus this minus this plus this minus this, so plus 6 also. So here 5 plus 3 8, here plus this 8 plus 6 4 minus 3. So 14 minus 3, no? Here it was 3, right? Yeah. 3 4 here. Yeah. So 3 minus 3 14. Or yeah, it's correct. So guys, what we are doing here is very simple. We go here for I equal to 0, I is less than n, I plus I less than equal to m. Okay, and it start from 1. Okay, here for enter j equal to 1, j is less than equal to n, plus here what we will do is prefix of I comma j is prefix of I minus 1 comma j plus prefix of I comma j minus 1 plus matrix of I comma j minus prefix of I minus 1 comma j minus 1, right? Here prefix is this minus is yeah. Oh, yeah, right. Here we can go out of bound here, because here this matrix should be I minus 1 comma j minus 1, because we are taking the index here, right? Like this. We have all the sums, right? Now we have this. So what we will return in this case, we will return, let's say, we are asked the sum of this rectangle, right? This rectangle. So let me clean this first. And now let me show you here. Let's say we are asked to sum of this rectangle, right? Here. Now this red one. Okay. So we have here the all sum of the all this rectangle, right? So what we have to erase? We have to erase this rectangle. Means what? And we have to erase this rectangle, right? So how do we get this like row and column? Row will be same. Row will be the like let's say row 1, 2, 3, 4, 5. So we have 5, 3 and 3 row, 2 column, and 5 row, 4 column. Here what we do, whatever the row, column will be same. So 2 row, column 4. We have to subtract this sum, right? And column same. Row is the old one, 5 row, column 1, right? And we have to subtract this. Then after that we have to add this, right? Column of row 1 minus 1, column 1 minus 1. Then we will end up here, and we have to add this sum, right? Because we have to we have subtracted this twice. Okay. So in this case, what we can return is prefix of row will be same, right? Row will be same in this case. If row is same, like row 1 minus 1, right? That means if we are like row 1 minus 1, that means row will be same. Row 1 is here like same, because it is already minus 1 in this case, right? And column will be 2, right? Call 2 plus 1 in that case, right? Here we are this plus column will be prefix, column will be same, which means what row will be 2, right? Row will be 2. So row 2 plus 1, column will be this column 1, right? Add this and minus that thing, prefix of row 1 and column 1, right? We have done this. Can we make it run, guys? Assign. Okay, let me check the code in this. AWSIGN is there, okay. So if it is there, then why my version? Cross in. Oh, here. Okay. Now. It's running or it's wrong answer, just it. Okay, let's check what is the right answer. Everything is plus 1. R2 C2 minus R1 minus C2. R1 minus 1 C1. Okay, it is this. Row is same, column minus 1. Row minus 1, column is same. And this is also. Okay, this I have to minus. Alright, let's do this now. No. What was the return statement? Here, return like prefix of row 2 plus 1, right? Whatever it is, and column 2 plus 1 minus this and minus this and plus this. What do you say, guys? Yeah, that is running. Accepted, guys. Okay, it's quite good actually. Thank you so much for being with me, and we'll meet you in the next